All right, let's start with this example. You can actually pause the video and try it yourself, but remember we're dealing with single variable here, okay? So now they are saying, prove that this left-hand side is the same as right-hand side. So you're not solving, you're just trying to prove that what you have here is the same as there. You can actually do it also going this way or going that way. Doesn't matter. Just depends on what's easier for you. Okay. So let's try to start with the right-hand side, the left-hand side, sorry. All right. So we say left-hand side. Okay. You have to show which side you are actually going to work with. So I'm going to work with the left-hand side. So this is going to be S sine X, which is same as sine theta, because this is an angle. X plus sine 4x, right? Like that. So we're trying to prove. Now you need to look for patterns. What pattern can I look for? I'm looking for one of those identities that we looked at that could be of use here. All right. So I'll try first of all to factorize, because this is like any other variable that you've just squared. Okay. Any other function that you've just squared. So I can actually factorize this. And then here, that's 1. So I have cos squared x. Then here, this is power 4. I've removed 2. So I'll have sine squared x. Right. So I continue with my simplification. Now, I need to remember the identities. Okay, which one I can apply. So we remember that we said that sine squared x or theta plus cos squared theta gives you 1. So here we have to show, to say, maybe you can write, but cos squared x plus sine squared x is equal to 1. So now you replace in the function or in the statement like that. So you have sine squared x. So you've actually shown that the left-hand side was the same as the right-hand side, right? Let's look at, you can actually even do the right-hand side. So here you're going to introduce a 1. So you can, for example, do this. You say sine squared x, then you introduce a 1. Then you say, but 1 is equal to this. So you put sine squared x, and then you put sine squared x. Or if you want, you start with cos to make it exactly the same, cos squared x plus sine squared x. Then you're going to multiply, you're going to expand this. So this will give you sine squared x, cos squared x, plus, then this one gives us 4, like that. So you've also shown from the right-hand side that it's the same with the left-hand side. Okay, that's our first example. Let's look at example number 2. Right, this one is a bit weird, but we'll still solve it. So this one, I'll use 2 stages, right? So you can pause and give it a go on your own, but I'm going to go from left-hand side and show that it's the same as the right-hand side. So I'll use this function here, right? So what do we do here? I'm going to split the first one. So I'll have cos x, cos squared x over 1 plus sine x. Right. So that's my split. Then I can recognize this from, remember we said this is very important, is equal to 1. So now I'll make this one as a subject of the formula, which means that I'll have cos x, then here I'll have 1 minus sine squared x, like that. Then I should divide with my 1 plus sine x. Now, what other pattern can I see? I can see difference of 2 squares here. So I'm going to do that. So I'll do cos x. Okay, here I'll do 1 minus sine x. Then I'll do 1 plus sine x. Then I divide the whole thing by 1 plus sine x. Now we see that these two are the same, right? So it means that this is what remains, which means that this is cos x 1 minus sine x. Now, if I look at this, it's not yet there where we need to be. So how can I convert this to these two? Okay, how can I convert this to those two? So what I'll do is I'll say tan theta, remember the other one, is equal to sine theta over cos theta. I'll make cos my subject of the formula, so I'll say cos theta is equal to, tangent goes there, so we have sine theta, or sine x, used to saying sine theta, over tan theta in this case, or we can put x later. All right, so we have this now. Again, this is not the final thing. So I can do the inverse of this one and inverse of that one. So I can have cos theta. Okay, I can do the inverse of this one. It'll be the same. So I'll have, because we said that sine theta, for example, is the same as 1 over cosec theta. We said that these are inverses of each other. So here I can have 1 over cosec theta. Then this one, the inverse is cot, but since it's dividing here, cot will be on top here, cot theta. So meaning that cosine theta is equal to cot theta over cosec theta. Now you will see that this is actually the same as this and that. So now we can get this and introduce into that function. So we'll have cot theta or cos x over cosec x, then 1 minus sine x. So the identity is the same now. You see that the cot is there, the cot is there. Cosec is here, cosec is here. Then we have 1 minus sine x, 1 minus sine x. Required a bit of innovation here, but it's the same because we can prove that cos theta is equal to cot x over cosec x. The easiest is obviously maybe to prove it from here going backwards there. All right, let's try another one. All right, so the same one, let's try to show it from here going this side. So we have cot theta, cot x, 1 minus sine x. Okay, then we have cosec x. So what happens here? We're going to try and simplify this. So this one will give me cos x over sine x. Okay, then we're going to have 1 minus sine x here. All right, then the whole thing divided by, we're going to have 1 over sine x. Right, so this is going to go up there. So we'll have cos x sine x over sine x. Then we have 1 minus sine x, like that. Right, so remember, we're targeting cos 3 here. So here and that goes. So I have cos x, right? Then I have 1 minus sine x. All right, so now we've landed here. So we've got to think hard now to see how can we get our cos. So here, essentially, we're just looking for cos squared x, okay, to give us cos 3x. So here, what do? We're going to maintain this one, okay. We're going to maintain this, but we're going to multiply with the conjugate of this one. So it will be 1 plus sine x. Then here also 1 plus sine x. Right, so now this and that are difference of two squares. So we're going to have cos x, right? Then here we're going to have 1 minus sine squared x. And then down here we're going to have 1 plus sine x. Okay, so now we remember that we had that identity which said that sine squared x, cos squared x is equal to 1. Right? We can remember that. So if we made cos squared x the subject of a formula, we'll have 1 minus sin x here. So meaning that we can have cos x, and inside here we can have cos squared x, right, over 1 plus sine x. Okay, so now these can be combined together, so we can have cos 3x over 1 plus sine x. Right, so this would have given us the same situation as what we have here, meaning that we've proved from left-hand side, from right-hand side, okay, to left-hand side. Okay, the first one we actually proved from this to there. This one we proved from here to there. All right, so let's try another one. All right. Okay, how would you go about trying to solve this? Right. Okay, so you can pause and give it a go. We're still using the same identities that we looked at, nothing else. The inverses, we're using the Pythagorean, and then we're using the tangent. So we're using just those three identities. So we haven't gone into the other complex ones. Well, there's nothing complex, but we haven't gone into the double angles, we haven't gone into the half angles and all that. So here now, how would you solve this? Right, so it's always easier to go from many to a few. Okay, it's a little bit difficult usually to go from here to there because you don't know what has been taken away, right? So the best is always to go from many to few, unless otherwise, right? So let's start with this. And the first step that you have to do is you have to get the basic functions. And the basic functions we said were cosine and sine, because these they make up everything else. So whenever you see something that's not cosine or sine and can be converted, you try and convert it, especially if these made up ones are not part of the answer here, right? So I can see tangent, I can see sec. So my immediate thought is, let me try to convert these into the basic ones, which is sine and cosine. So I'll start with sine y, right, plus 1 over, not 1 over, so that's sine y over cos y, right? The next thing that I need to be aware of is that I'm dividing this. I don't want to have division, then division here. So what I'll do is I'll go to basic division operator here instead of using this one here. So I'll say 1 plus, here I'll have 1 over, we said that this is cosine, so we'll say cos y. We'll say cos y. What else can I do here? I feel like I can simplify these two, right? So I can say sine y, cos y, plus sine y, right, over cos y, divided by, this becomes what? This becomes cos y plus 1 over cos y, right? So what else can I do? I can change this to multiplication sign. But then before I do that, I can also factorize the sign. So I'll say sine y, like that. Then I'll have in brackets cos y plus 1. You see that? Then here I'll have cos y. Then this has changed to multiplication, so this comes on top, so it becomes cos y over cos y plus 1. Now I can see that this and this are the same, that and that are the same, giving me my final answer there, which is sine y. So you can see that we've proved that this is the same as that. Okay, or I can say here is equal to sine y. This is the same as that. So we've proved. Okay, it'll be very, very difficult to come from here to there because you didn't know that they actually had to cancel these. So now you cannot just guess that you need to put this back to get there. You can get there, but it's very difficult. So it's better to come from many to few. All right, let's look at another example. Okay, so now we have this identity. So how can we show that these two sides are the same? Like we said, our first suspects are always going to be from the big side to the small side. And our first work must be to simplify these, like this one, to the basic one, which is sine or cosine. So in this case, it will be cosine. So let's simplify this. Let's see cos. So we'll prove the left hand side. So cos theta. Here we have 1 over cos theta minus cos theta, like that, is equal. Oh, okay. No, we don't need to show. Okay, we're just doing the left hand side. Right. So we continue cos theta, like that. Then here we simplify. So we have 1 minus, then cos theta will give us cos squared theta. And then here we have cos theta, like that. Then these can take care of each other. So we have 1 minus cos squared theta. Now we remember our functions. Okay, remember our function. Sine squared theta plus cos squared theta is equal to 1, meaning that this sine squared theta is equal to 1 minus cos squared theta. Right, so this is the identity that we're going to use here. Right, so we're at this stage, so we can take this and replace into there. So we can say now 1 minus cos squared theta is the same as sine squared theta. And then we can check the right hand side is the same. So we can say right hand side is the same as left hand side. So we've proved our identity. Okay, let's go to another one. We said that our strategy is always to look at the side that's larger. So this is the side that shows that it's got more elements, right? That's our first strategy. Then we said that our next strategy is to see where these are not in basics. So we see that these are in basics. So now are not in basic function form. Like this one should be in cos, this one should be in sine and cosine, but they're not. So what do we do in that case? In that case, we go with the side that's got more. Okay, as a rule of thumb. So here I've got more elements than this side. So I'm going to prove the left hand side. I'm going to use the left hand side to prove that it's the same as the right hand side is the same as the left hand side. So I'll start with this side. Okay, I'll start with the right hand side. Okay, we said we're going to use the side, so I quickly get that side. Everything, mostly mathematics, it's just simplification. Okay, that's where you find your answer. So here, let's simplify. So we're going to have a common denominator here, which is 1 minus sine x, right? Then we're going to have 1 plus sine x, like that. Then we're going to have, on top here, we're going to have this into there. It will give us this, so we'll have 1 plus sine x. It's like adding normal fractions. So here, this will come and cancel with that, then it will give us this as the numerator. So we'll have 1 minus sine x. Okay, let's simplify the top part and the bottom part. Here we can see it's difference of two squares, right? So if we have 1 minus x times 1 plus x, remember what we get? What we get is 1 minus x squared. It's the same here. So we'll have 1 minus sine x squared. So here, let's simplify this. So here we'll have 1 plus sine x. Then this is minus 1. Okay, minus 1. Then this is plus 1 plus sine x. Okay. Then at the bottom here, what we have at the bottom here, we're going to have difference of two squares, which is 1 minus sine x squared. sine squared x. Okay. What happens here? What happens is that this and that shall cancel out. Then we have 2 sine x. Right. Okay, so this is 2 tan x sec x. Right. So now here we can see we've captured it too. So we know we're going in the right direction. Then here at the bottom, this is our usual Pythagorean identity. Okay, so this will give us cos squared x. We should be used by now. Right. So we come here, we say 2 sine x over cos squared x, like that. Okay, now what next? What next is we're going to be careful here. We're going to separate them 2 alone. Then we have sine x, right? Then remember here we had cos x, like that. Then what's remaining? Another cos x. So we're going to have 1 over cos x. So we can see 2 becomes 2. This, we know it's our first identity. That's why we said we need to know it by heart and so identify it every time we see it. So here we have tan x. Right. And here we have sec x. Okay, because we know this is the inverse of the cosine function. So this is the cosec, the inverse of the cosec function, of the sec function, sorry. Okay, so now we have this. This is what we've obtained from the left-hand side. So we can say left-hand side is equal to right-hand side. So we've proved our identity. Okay, so I think these are the tricky ones that I thought we could go through. We are going to look at the double angles, half angles, and some other types in our next session. But for now, practice these as much as you can so that you make them your first nature. All right, all the best as you practice, and please remember to share, remember to subscribe, and like the video. All the best.